proof. This time we are trying to prove an expansion in a summation notation, right? Now to begin the proof, we can start from here, right? We can start from a very simple expansions like this, 2 to the power 3, right? So we can try to expand this. Okay, now in this case, if we try to expand that, we can do it slowly like this. And then we can apply binomial expansion, which is here. Oh, sorry, that one is not dry. Hold on, let me get that down. Okay, from here we have the okay, let's see how we want to do it. We can actually do it this way. That will be alpha 3, for instance. And then we will have the 3 alpha 2. And then after that we'll have this 3 alpha. I think this is much more easier. And then after that we have this one here. Okay. Right. Now thereafter we can further expand this section here. So we have here we can expand this. That will be here alpha beta alpha gamma. And then from here we're going to apply the same binomial expansion that we have, depending how you want to do it. This is just my way of doing the expansion. Right. So that will be a 3. Sorry, I forgot that. Then there's a 3 beta gamma square, and then finally we have that gamma cube. So from here is better to group those like term with the same order. So in this case we're going to group the alpha 3, beta 3, and then gamma 3. Okay, that will be considered as one group here. Hold on, just let me clean up this. This is gamma 3. Okay, so we have just to highlight that in case I miss out any term. Okay, I'm done with that. Now next I'm going to group those also like term with almost the same degree, like this one here and this one, for instance. Okay, we'll do that by taking out 3. Let me see whether I can do that. Maybe alpha square. Can I take out alpha square and so on? Yeah, better not, because in this proof here we don't have the alpha square. So maybe it's better to group with the rest. Let me see. This is alpha, beta, alpha. Okay, so we have that. We have this here. Okay, that will be. Let me see. Okay, so we can try this out maybe. Okay, so let's try this method first, since they sort of share the same alpha square here. So I might want to group this together, or I can actually group this with this also, right? Like beta gamma. Okay, beta gamma, and then alpha beta, for instance. Okay, let me see whether I can group that. Now in this case we can have, let me rewrite that. Then here we have, and then the rest of this you will have 3 alpha beta plus 3 gamma here. Did I get it right here? Alpha square. Okay, I know what went wrong already. Hold on, there is okay, I spotted my mistake here. Hold on, just let me clean up here. I think I've done a terrible mistake here with my expansion. Just let me correct that. I just spotted my error. I forgot my square there. Okay, so let me just try that again. So we have here, I'll try to expand this. So we have alpha square gamma, and then here I will have 3 alpha beta square plus 2 beta gamma plus gamma square. And then the same goes here. We have beta 3 to about 3, and then we have 3 beta square, we have 3 beta gamma square, and then finally we have gamma cubed. Right, now the same strategy would apply here. We are going to, okay, I'm going to open up, I'm going to group all this together, all the like term with the same order. So in this case I will have alpha 3, beta 3, and gamma to about 3. So there's one group, and then the rest I just rewrite them again, and then we'll see what we can do with this. So we have 3 alpha beta square, we have 6 alpha beta gamma, we have 3 alpha gamma square, and then here we also have 3 beta square gamma, and then finally we have this gamma square here. Okay, now the 6 we're going to leave it out. We're going to factorize the rest if we can. So we see whether we can do anything with this one here. Let me see. We can take out alpha and gamma, and then we can take out alpha. Yes, correct. Okay, so let's give it a try. Okay, so from here we can try to factorize this. Okay, so let's see here. I can see that there's a beta square here, there's a beta, right? So maybe it's best if I can group this one beta square, alpha square. Okay, alpha square. So if I group them, I will have, let me see. Okay, or I group this, so there will be alpha gamma, alpha gamma. So maybe I can do something with this one and this one, for instance, because they seems to have alpha gamma, and then I can actually deal something with this one and this one, since they have alpha beta, right? So I'll deal with these two, and these two here, and then most probably these two. You can see they share more or less the same, so we're going to do that. Okay, now first of all, I'm going to group this one first. Just let me circle that so that you can see this. Okay, this one and this one. Okay, that would actually give me 3. I'm going to take out alpha beta. So from here, if I take out alpha beta, I will get an alpha. Here, if I take out, I'll get a beta. And then I might as well add another one though. It seems like there's one missing here. So since I'm adding up 3 alpha beta gamma, so I need to get rid of that 3 alpha beta gamma. Now that would be my first factorization for these two. And then I'm going to repeat the same process for the rest, which is 3. Now I'm going to do this for this one and this one here. So 3 alpha gamma. By taking out that, I have alpha, and then taking out that, I will have gamma, and then I might as well add on another beta there. So I need to take out beta gamma there. So I need to take this out. And then lastly, I'm going to repeat the same for the last one here, which is 3 alpha gamma. Okay, by taking out 3 alpha gamma, by taking out 3 alpha gamma, did I take out the same? Oh, sorry, I took the wrong term. I should have taken the last one beta. So 3 beta gamma. So from here I'll have beta, I'll have gamma, so I can add on another alpha here. Therefore I need to remove 1 beta and gamma there. So that's my third term. And then don't forget I have the last one here, which is plus 6 alpha beta gamma. Now that's what I have. And then you can see here we have this is negative 6 alpha beta gamma, so cancel off with that. We're only left with 3. So we have 3 alpha beta gamma. And the rest, you can see that they share a common factor here. Therefore, I can factorize them. Yeah, so let's give it a try. So if you factorize all this, you can see all these are the factor, and then the 3 also. So we can actually factorize the 3, and then alpha, beta, gamma. And then once we factorize this, only left with alpha, beta, and then here will be alpha, gamma, and then lastly you have your beta, gamma. Okay, and then finally we have the excess of 3 alpha, beta, gamma there. So that's what we have. I'll just rewrite this down here so that it's easier to see here. And then thereafter we can actually use a summation notation to represent this. This is basically the sum of all of this cube. You can see this is the sum of all this. It's a short form way of representing this summation. And then the same go for this one. Then same go for this one. And then finally this is the one. All right. And then by rearranging, we managed to prove that this is the same as this by moving the rest of the term over to the other side. Of course, not to the dark side, to the bright side in this case, to the summation side. And then there you have it, proven. Okay, so I hope that will be helpful to you. All right.